Hello everyone, this is Keith Jackson and welcome to Jack's Math Notebook. In this video, we're going to show you two ways to factor completely quadratic equations. And we have big example one and big example two to show you how those two methods will work. All right, so in big example one, we have 3n squared minus 15n plus 18. Okay, so now what we could do, we can use magic X by multiplying a times c, which is 18 times 3, but we don't have to do that because we can actually factor out a 3 out of this quadratic equation. And so we can do that by dividing everything by this 3 here. And so we know that 3n squared divided by 3 would just give us 1n squared or n squared that you see right here. And we know that a negative 15n divided by 3 will give us a negative 5n. And of course, 18 divided by 3 will give us a 6. And so now we have n squared minus 5n plus 6 with the 3 parked outside. Okay, now all we have to do at this point is figure out what are the two numbers that multiply to a positive 6. Well, at the same time, when you add them together, will give us a negative 5. And those two numbers are a negative 2 and a negative 3, because a negative 2 times a negative 3 will give us a positive 6. So we're good there. And a negative 2 plus a negative 3 will give us a negative 5. And here we are right there. Now we're going to use those two factors right here to help us complete our factoring process when it comes to this particular quadratic function. All right, so let's plug in n minus 2 here because we have that negative 2. So we've got n minus 2. And then we're going to have n minus 3 because we're going to use that right here. And so before we test it out, before we actually figure out what our roots are or our x-intercepts are, we're just going to see if n minus 2 and n minus 3 actually will match this quadratic equation up here. And here's what we're going to do. We're going to multiply this 3 times the quantity of n minus 2, and then after that, we're going to use box method to see if it will bring us back to our original quadratic function. And so we're just going to distribute this 3 inside the parentheses that you see just like this. We're going to do this and we're going to do that. And when we do that, we'll get 3n that you see here, because 3 times n will give us a 3n, and 3 times a negative 2 will give us a negative 6, just like you see right here. And we're just going to leave the n minus 3 as is when we perform our box method procedure. And so we have 3n minus 6 on top, and we have n minus 3 on the side. And so when we multiply n times 3n, we're going to get 3n squared. Okay, that works because we have it right here and we have it up here. And n times a negative 6 will give us a negative 6n. Good, because that's going to work out so far so good. And now we have a negative 3 times a 3n, and that would give us a negative 9n, which lets us know that a negative 6n plus a negative 9n would give us our negative 15n here. That's good here, and that's good there. And of course, a negative 3 times a negative 6 will give us a positive 18. Yes, those factors work. All right, so we work them out. Now we have to figure out what our roots are. But all we have to do in order to figure out what our roots are, we're just going to set n minus 2 is going to be equal to 0. And the reason why we want to set it equal to 0 because that's where our x-intercepts are going to be. And we know that in order for this to be equal to 0, then n has to equal 2, right? Because 2 minus 2 equals to 0, so n is equal to 2 here. So that is one of our roots or one of our x-intercepts. And let's do the same thing with n minus 3 because we want to figure out what n is. And so when we do that, set it equal to 0, we know that the only number that will make this equation equal to 0 is that n will have to equal to 3. And those are our x-intercepts, y'all. And that's how we factor completely this particular quadratic equation. Your teacher will accept this form right here, but if your teacher wants you to go further and find the roots, this is how you do it as well. And so the factored form, the completely factored form would be 3 times the quantity of n minus 2 times the quantity of n minus 3. Okay, let's move on to big example 4 and do the same thing. And in this case, oh yes, whenever possible, please factor it out. Please simplify whenever possible. And that's what we're going to do here because we can simplify this out by dividing everything by 2, because 2 is a factor of all these numbers that you see right here in this particular quadratic equation. And let me repeat that quadratic equation, which is 4x squared minus 18x plus 14. And in this case, we are going to use magic x method that you see right here. We're going to multiply a times c, and we're going to put ax here, and then we're going to put our new b right there. We're going to show you how that's done. And so now when we take out a 2, factor out a 2 right here, we will get this, because 4x squared divided by 2 will give us 2x squared. A negative 18x divided by 2 will give us a negative 9x. And 14 divided by 2 will give us 7. And so this is what we have right here. All right, a more reduced form, a form that is easier to figure out the quadratic function, or I should say to figure out the factoring form of this quadratic function. And here's what we're going to do. Now we're going to apply the magic x by multiplying this 7 times this 2, which will give us 14. And then our b right here is going to be a negative 9. And the question remains, okay, what two numbers, when I multiply them together, will give me a positive 14, but when I add them together, that will give me a negative 9. Keeping in mind that I have my 2x right here, I have my ax, 2x is the ax, so I'm going to put the 2x on this side and the 2x on this side right here. And so those two numbers, by the way, are a negative 2 and a negative 7, because a negative 2 times a negative 7 will give me a positive 14 that you see up here, and a negative 2 plus a negative 7 will give us a negative 9 that you see right here. And so those are the two factors we're going to work with, and I'm going to put that negative 2 right here above this 2x, and then I'm going to put this negative 7 above this 2x over here, and we're going to work our magic. You see, in this particular case, a negative 2 divided by 2 would give us a negative 1. And of course, when I cancel this out right here, cancel that out, it will equal that negative 1, because a negative 2, again, divided by a positive 2 would give us a negative 1. But guess what? We leave this x, and this is the x that we're going to put right here. And so now we have x minus 1, all right, because we simplified it. But in this case, we cannot simplify it, so we're just going to write these numbers as they are. So we're going to put the 2x right here minus the 7. Okay, and we're going to test to see if this works. And now we have our 2x minus 7 on the top and our x minus 1 along the side. And we're going to see if it's going to give us back our original quadratic equation. And so when we do that, we have x times 2x, and that will give us 2x squared, and x times a negative 7 will give us a negative 7x. So let me repeat that. And x times a 2x will give us a 2x squared, and x times a negative 7 will give us a negative 7x. And so we're finished with this top row. And let's go ahead and work with the negative 1, because a negative 1 times 2x will give us a negative 2x, while a negative 1 times a negative 7 will give us a positive 7, and it all works out right here. And so what we could do, if we like, okay, your teacher will be very happy with this form of the quadratic equation. But if your teacher wants you to find the zeros, the x-intercepts, here's what we're going to do. So I'm going to take this 2x minus 7, and I'm going to set it equal to 0, right? And so what I'm going to have to do, I'm going to have to add 7 to both sides. And so now we have 2x, okay, is going to be equal to 7, but we're not finished yet, because we have to get x all by itself by dividing both sides by 2. Okay, and when we do that, we will get x, in this case, will be equal to 7 over 2. All right, and so and that will be our 1, 0 right here, our one root, if you will. Okay, because roots and zeros are the same thing, and x-intercepts. This is where this x is going to crisscross this is where this is going to crisscross the x-axis right here at 7/2, all right, or 3.5. And then right here, we're going to set this equal to 0. And if we do that, okay, if we set that equal to 0, we know that x is going to have to equal to a positive 1. So our other root is at a positive 1. Okay, you have been given a lot of information. I wouldn't blame you if you need to pause the video to take a look at things, or replay this video as many times you need to gain a deeper understanding of this concept. But in the meantime, please comment, share, like, and subscribe to Jack's Math Notebook for more content. Thank you and goodbye.